Alright, hello everyone, and welcome back to Satisfactory, where we are continuing to work along on our Phase 4 project parts. Now this time is going to be a bit of a doozy, because we are going to be doing thermal propulsion rockets, which, if we just look this up here, we've got 4 things here, all of which are complicated. So, step 1 is going to be figuring out what we have spare that we can use. So we have modular engines, for example. I believe we have 10 of those. Although let's actually just go and check in person, because that will make this process a little bit less boring. And also, it's good to just confirm that the factories I think exist actually exist and are actually doing the thing that I want them to do. Wait, no, I'm dumb. I don't have rocket fuel on me apparently. Okay, let's respawn real quick. Where did all of my packaged rocket fuel? I have plenty, but I guess you have to land with it active in order for it to recharge. Okay, so we have to move this tube back facing the other way, because I forgot where the modular engine factory was. And it's going to be this one over here. So let's fly on over here and land. Alright, so now we're here. We have all this stuff going, and it looks like it's at 100%, and each of these are doing 0.833. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. So that should work out to 10 modular engines. So I can go in here on my tools website and add modular engines 10. Cool. That's going to help a little bit. Then we have our turbo motors, which I think we might be able to fully handle. We should be able to if the calculations are all correct and the factory is working right. So let's respawn real quick, because I believe turbo motors are over this way. I actually just don't know where they are. Is that them? That is... no, that's not them. That's supercomputers. Okay, it's here to the southwest. And it's pretty close, so we can just get over there on foot. And hopefully this factory is working at 100%, because then we can chop turbo motors off of the production line and save a whole lot of effort. Probably the single biggest part of the effort. If it isn't working, we're just going to bug fix it until it does. And if it's being sent somewhere else, then that would be sad, but I don't think it is. Up we go. Got all sorts of green lights in various places. Have to make it over this way. And we have radio control units and those. Alright, this is working. How many of these are there? 1, 2, 3, 4, 5, 6. 1, 2, 5 times 6 is 18.75. So this is the correct amount of turbo motors, because we need 10, right? Thermal propulsion rockets. Yeah, there's we need 10 of those, so we can just add those in. Turbo motors. We've got 10 of those with a couple spare. Then we have cooling systems, which I think I don't actually automate anywhere like permanently. I'm pretty sure I just make them within the supercomputer and use them there. So we're gonna have to deal with those. And then there's the fused frames. Now, fused frames I remember being a little scuffed. We used them for something else. Although I can't remember what. We used fused frames for something else, so I don't know if we're going to have all of them available here. Alright, so now we just have to get over to this. And it looks like it is functioning mostly. I see yellow lights over there. I'm pretty sure we're using them in, what, the ACUs or something? Alright, so we've got these. They're running at 12% because of aluminum shortages, as always. Of course. And none of these are going super well. But we do have aluminum currently. And this is the train that does that. We've got a couple hundred in there, a couple hundred in there. More significant chunk in there. Alright, so this is clearly not enough. This is clearly not enough, which means we're going to need to fix it. However, what else are we using fused frames for? We're using them for pressure conversion cubes for the something or other. What is it, for supercomputers or something? No, for turbo motors. Alright, so we're doing this. And this is supposed to be like that. So we're going to be using like slightly less than 10 of the fused frames on that. Which means that we will be getting... We make 15 of these, right? Yeah, so we make 15 of these, which means we have like 5 available, which, if I'm correct, is not nearly enough. It's like half. It's like half. That's something at least. Although it won't really help with the complexity problem. Our fuse frames are used for other things too, right? We're going to need... Well, I mean, technically it's just pressure conversion cubes and thermal propulsion rockets. So I guess we're going to have to make more fused frames at some point anyways. So we might as well do that now and leave this 5 production for actual crafting. Because if we take 5 over here, we're going to be left with basically none for crafting, which doesn't seem fun. Alright, so I think that's where we're going to leave that. And now we can go here. And let's see here. How much did that help? I'm just looking at the schematic now. It's kind of a mess, but it seems to have helped a fair bit. We don't need quite as much fresh aluminum going in now, although we still need a lot. So let's add that in as well as another input, aluminum ingots. aluminum ingots, and we are going to just say like 1,000 of them so that it just assumes we have all that we need. To cut that out, and then we will have to upgrade our aluminum production almost certainly. So what are we left with? We are left with like 1,200 iron, 200 copper, 1,100 crude oil, 400 limestone, almost 700 nitrogen gas, and then all sorts of other random junk. Alright, so this is going to be a whole giant process. Step 1 is... Charles, hello. It's been going well. Yeah, no problem. You know, just I don't expect people to stop by every single stream, you know? Nice to see you back. We are working on thermal propulsion rockets now, and we're just about to get started, and it's quite the task. Yep. Alright. So where is the aluminum input? We have all of that going in. Alright. Just staring at this for a bit. It might not have put in enough aluminum ingots. Let's pop another 0 in there to make sure that we have enough, so that it doesn't try to do it that way. Alright, so we are going to need like 1,330 aluminum ingots for this, which is quite a lot, but it does chop down the crude oil requirements a bit, and some of the other requirements as well. Alright, so step 1 is we need to increase our aluminum production yet again, because this is, I mean, it's not enough to keep going what we have right now, much less add more stuff in. Although it's at least close-ish. I mean, these are decently filled boxes, I guess. But we're going to need to add in another multiple full belts of aluminum, probably. So let's head over there and get that all set up. So we just slide on over. Off we go. So we just have to make it all the way over here. It is quite the journey. It's a good thing we have these nice straight platforms. This journey would be absolutely unmanageable on ground level, but up here it's just kind of mildly annoying. So we just have to get all the way over to our aluminum factory and work on expanding that and potentially fixing it if it isn't currently functional. So yeah, that's step 1, is get probably 3 more full belts of aluminum ingots out, because we need more for what we're already doing, in addition to what we need to be doing in the future for the thermal propulsion rockets. Alright, so here we are. And is this functional? Looks like it. Let's see, these are a little bit concerning. Don't know why they're at 80-some%. But it's probably fine. These ones over here are working just fine. And then these ones over here are all going great. So that's good. It's good that we have at least some of these guys functional. Chalk it up to fluids, who knows? Yeah, that's probably it. To be fair, it also might be It also might be like not enough bauxite input or something, because trains make that very hard to tell when that's the case. But yeah, it's probably just fluids being funky. So how is our bauxite? Currently we have more than enough bauxite, and it's being distributed pretty evenly amongst all the places we're sending it. Now if we add 3 more full belts worth, we're going to just break everything, I think. So that is not going to be pleasant. Alright, so we first need to get the additional belts out of this. And then we need to find out where to put them, I guess. We really need to redo this whole system, because this is absolutely not like an ideal way of distributing things when you want to add stuff to it, which is what I currently want to do. It was scalable up to a point, and we've reached that point, basically. Alright, so the train is here, and it's delivered, and it's still got plenty of spare bauxite. So we might not have to add more bauxite mines. Unclear. It would be really nice if we didn't have to add more bauxite mines to this. Okay, we have another bauxite train coming around right now as well. Alright, probably don't need to add more bauxite mines unless this one's like nearly empty and is also full. Alright, cool. So the ore is present. We just need to get it somewhere. Now currently I have, if I recall, this is 480 bauxite. This is 600. So those two combined make more than one max speed belt. Then the rest of these two are 780 each. Which means we're gonna need like basically doubling this entire thing, if not more than doubling. Okay, slightly less than doubling, I think, but that's going to be a lot of bauxite used. And now we do theoretically have, because these are all going off of individual single belts. So we can just grab one extra belt from each of these 5 and then add them all in. Getting them around, I guess we can build it back here in this open space. Yeah, let's do that. So, step 1 is all of these go down. What's the spacing like? It goes down there. Alright, so you go down there, and we just have to get one for each of these. So let's get the floor holes in so that we can set that up. There we go. So now all of those can go down, and we can get them underneath and over to here. So then what we need is, we probably don't need another one of these things, although it might be necessary actually. Hang on, let me think. If we're just adding 5 full belts in, then it should be fine regardless. If we add 5 full belts in, then each of these can just take from one of them and it'll be fine. Yeah, let's do that. And we're if we do that much, we're definitely going to need to mine more bauxite, because we do not have that much spare. But we can at least get it set up and then go and add the bauxite in later. Alright, so this area can be the start of that. And then we just need to get those belts over to here, which we can just go... Actually, we're going to need them to be spaced properly, so I guess we can just do one at a time. So this is bauxite to alumina. Is this the correct speed? Let's just place it down and see. So you can go in there. And you are, let me guess, 600? Or even 480? Yeah, okay, so that's not what I want. We need... What's the button for dismantle mode? There it is. We need the bigger blueprint, which... Aluminum ingots Mark 5 is later in that line. Aluminum scrap. That makes 960 aluminum scrap, which is for this one. So that is that. Where... I know I have a blueprint of this in here somewhere. I just don't know what it's called. Did I, like, not actually make it a blueprint? Let's see, actually, if I just go over here and swap to dismantle mode blueprint, I'm not getting anything. Alright. That answers that. This was not actually a blueprint. This was just manual construction. Apparently. Although, I don't believe that. This is too uniform, right? Maybe this portion was a blueprint? Alright. Why do I keep hitting the wrong button over and over and over again? My hand gets, like, slightly off, and it all gets messed up. Alright. Any of these look correct? No. So, let's make a blueprint, because I want to have one. So let's go over here and slap down a Blueprint Designer Mark II. Can we fit 5 refineries side by side in this? We might only be able to do 4. Alright, so this goes in here, and I think we want as much room in the front as possible, so just leave, like, even that much for the outputs. 1, 2, 3, 4. Yes, so we can only get 4 in a row here, whereas this requires 5. And those two are at 58.5%. It's so close to requiring 1 fewer. Let's see here. Is there any way for me to make that better? Not really. I guess if I were to use like a VIP junction or something to get the water flowing correctly, but I don't know how to do that, and I've never done that, and I don't want to start. So, instead, let's see here. How much alumina is this making in total? 140.4 times 2 is 280.8 plus 218.4 times 3 is, make that a plus, is 936 total. So I can get 936 total over here, right? 240, 480, 720, 960 minus 240 times 4. Yeah, so we're almost exactly the right amount here. Except, of course, for the small detail of not being fast enough. Of not being split properly. So, we're going to have to... we're just going to have to use a VIP junction. I don't want to build this manually 5 times or use, like, miniature blueprints. So, in order to do that, what we need to have the fresh water going in and then have it be prioritized over the non-fresh water. Now the good news is that doing it this way makes the splitting a whole lot easier. So this is just, what, 936 divided by 4? And then we have that. So 234 times 4 is 936, and 195 times 4 is 780. That's how much bauxite we have going in on a belt. So we just have you and you. These are going to need to be Mark III belts right out at the end. So those all go in. Then this goes in and splits across. And then from here we just use Mark Vs there and there. And then we have our input right there. Alright, so next we have the water, which is what we're going to need to figure out now. So I think I remember how to do a junction like this. I'm pretty sure I watched a video on it like a year ago. Alright, so what we need is 2 fluid inputs which connect in to one main thing. Actually, so let's get this whole line set up first, and then hopefully I can remember how to do the fancy junction thing. So that, and that, and one more. So now those are all connected up. Alright, so we're going to go somewhere in the middle of them. Actually, this is less than 600 water, right? That's 195 times 4 is 780 water. Okay, well that's a bit of a snag. So this is going to be hard actually, because we need to have it go into 2 separate inputs. Let's see here. Actually, wait, how much, because we could like do multiple of these and then recycle their water back into other rows. That could be something. So let's see here. This is one of these ones. We need to be inserting 234 fresh water out of 780. And actually, we're going to have to go up to this row to see how much total water. Wait, actually, no, we're going to have to calculate it from scratch, actually, because the ratio is going to be different. Alright, so aluminum ingots aluminum scrap. So we have electrode aluminum scrap is the recipe we're using. And we have 7 water byproduct for 12 alumina solution. So that, let's get that right. 12 alumina solution makes 7 water. Then if we go into this and we go to sloppy alumina, 10 water makes 12 alumina solution. So that is basically two rows of this would give you 14 water, which you could use to fuel a third row. So hang on, let's see here. 2 rows of manually fed equals 14 spare water minus, so 3 rows of manually fed is 21 spare water. 2 rows of byproduct fed equals 20 water used, and that gives us 1 excess. I think those ratios are correct. So if we just go 3 and then feed their water into the other 2, then we'll have a little bit of water left, which we can just cycle into something, probably. I'm sure we can find some use for it. We could actually just, like, use it to feed one more tiny little thing. Yeah, okay, so let's just not worry about the water byproducts within this. So this is our blueprint. We're going to be making 234 times 4, 936 alumina solution out of 780 bauxite and water. So let's save this as alumina solution, which is 780 bauxite, 780 water to 936 alumina solution. Save and clear. Wait, actually, no. I need to unclear that. Where are you? Alumina solution. I just saved you 5 seconds ago. Why are you not in here? Did I give you a different name? Alright. Maybe I have to close this and then reopen it. And then, yes, and then it's out front. So we have to actually put a little bit of extra stuff in this. We need to put the output pipe, which goes here. And that just goes across. And we also need to get power poles in because there's no reason not to have these pre-attached. And so this is going to have to output to 2 separate pipes to get it all the way up, but that is not much of a problem. Alright, then we get our power pole, which goes 1, 2, 3, and 4, and now we just overwrite the blueprint. Save, confirm. Now we can clear. And let's get power over to the other side of the blueprint designer, because we've got a couple more of these to go. And we don't want to be able to only fly on one corner of the blueprint designer. Alright, so that is that. Next up, we have the other half of our setup, which is the scrap, which we need a little bit more space on the output side for, because we have two outputs. Let's go 1, 2, 3, and 4. And then this is electrode aluminum scrap and 180 per minute. So that is not going to be getting us our 936 alumina solution out. Did we have just like bigger sections for this up here? No, we had 4. I could have sworn these were the same ratios though. 180, 180, 180, 180. Okay, do these just not take... Oh, no, these are the new ones. Those are the old ones. And here we have a whole bunch of them there. Alright, so yeah, we're going to need, I guess, 2 blueprints of this or overclocking. How much overclocking do we need? 180 times 4 is 720. Now, if we were to use one of those, then that would be 270 times 4, which would be 1080, which would be more than enough. So we can do this with 1 power shard in each to get this within a single blueprint. So we need to get this to, let's see here, that, because that's 240, wait, no, that's wrong. Hang on, math time. So max production is 270 to 450, and we need the input to be 936 divided by 4. So we need the inputs to be 234, which means this has to be 234 over 240 times 100. No, that's wrong. Oh, wait. 234 over 2 over 180 times 100. Yes, alright, there we go. It's 390 scrap each. I guess I could have figured that out from the scrap side of things, since I know we're making 2 full belts of it. Alright, so we've got that in. Now we just need to get the petroleum coke split, which will be pretty easy because it's not even that much. I mean, relative to all the other stuff we're doing here, 78 is fine. So that all goes in like that. And then we just combine them up. And this is 78 times 4, which is 312. So we need Mark III belts there, and then Mark IV belts going in. And then we need our fluid pipe, which can go there and just across to there. Then the junctions go in. 1, 2, 3, and 4. 1, 2, 3, and 4. Alright, now let's get a power pole so that we don't have to spend as much time doing that once this is all set up. And the outputs. So the outputs need to get merged up into 2 belts of scrap. So like that, and like that. And then we have another one, which goes like that, and that will be 2 full belts of 780. And then we have our water, which is going to be less than a full pipe, I think. Alright, so then this pipe goes across. And we go 1, 2, 3, and 4. 1, 2, 3, and 4. Alright, so this gives 136.5 times 4 water, which is 546 water. And let's get that marked down. 546 water, because I need to write down the ratios for this. It's 936 alumina solution and what was it? 312? 78 times 4. Yes, 312 petroleum coke. Petroleum coke to 546 water and what is it? 1560 aluminum scrap. Alright, and then that is that. So let's get over here. And I might have already had a blueprint for this, maybe, but no, because the previous ones weren't overclocked. So this is aluminum scrap, and we're going to overwrite the other one. So this is 936 alumina solution, 312 petroleum coke to 546 water and 1560 aluminum scrap. So let's save this, overwrite the previous one, and clear it. Alright, now let's just see if this is right. So 546 times 3 is 1638 water. And each one needs minus 780 times 2 is 78. So we're going to have 78 spare water left over after all of this is said and done. And we can just shovel that into something, probably. I'll find a use for it. And then we need to make our 312 petroleum coke, which I have a blueprint for in here probably, right? Can I just customize that one? Alright, so we've got this, and this is making, oh, this is doing both steps straight from crude oil. That would be very convenient if we could get it to fit, but I don't think we can. So I think we can't do that, because we're going to have more refineries. So we can have a blueprint for each step of this process then. So we're going to have 1, 2, 3 of you make petroleum coke. 312 divided by 3. copy paste that across and get just a very simple fluid pipe in. And like something like that should be fine. Then these all get junctions and pipes going in. Alright, I unintentionally squeezed this a bit close to the back wall. Yeah, actually too close. Dang it, that's annoying. We're gonna have to dismantle this and build it just like one tick to the side. So all of this has to come out and get rebuilt. Actually, the main line probably could have fit. Alright, refinery goes nice and central in there, so that we have plenty of space in the blueprint. Then we get all of that. And we get our pipe going across. And we get those going in. Can we just paste that? Yes, we can. Oh. I accidentally hit the wrong button there briefly. Alright, then we just go to the back and merge these up into our petroleum coke. So we go like that. And these need to be Mark II belts going into the mergers. And Mark IV belts at least going down the main line. Like that. Alright, now we're just putting in the power pole, which doesn't need to be Mark III, but also doesn't need to be less than Mark III. It's not like we're short on high-speed connectors or anything. So this is our new petroleum coke V2. I want to keep the other one in case we want the direct approach. So this is, I actually didn't write down how much heavy oil residue it is. Alright. Yeah, so how much heavy oil residue is this? 34.667 times 3 is 104. 104 to 312. Petroleum coke V2, 104 heavy oil residue to 312 petroleum coke. Save, clear. Alright, so now we need 104 heavy oil residue, and I don't think there's going to be some clever way of doing this without making polymer resin, which we're just going to have to sink. So heavy oil residue, we're going to need 3 of these as well, and then they just need a crude oil input, goes across to there, and then all of those go in like so. Then you are set to this, which is what, 104 divided by 3, 34.667, unsurprisingly. It's the same ratio as the other ones. Then we get a power line in. Hello? What's going on? My build gun got messed up for some reason. It was not letting me click on hotkeys. Alright, so that is all powered up. And we need to get this in. So we need the outputs, which is polymer resin. And that goes like that. It's going to be a Mark I belt. So we can just do that. And then we have our pipes for the actual output we want, the heavy oil residue. That goes around like that. And then it gets all pumped into there. So then this is heavy oil residue. And it is, I once again forgot to check the numbers. It is 26 times 3. So 78 crude oil for 104. 78 crude oil for 104 heavy oil residue. Heavy oil residue. 78 crude oil, 104 heavy oil residue, and polymer resin, I think, like, I don't know, and I don't really care because it's just being sunk, so we're going to just write down it's less than 60. Alright. So we have a blueprint for that. We have a blueprint for that. I think we have everything blueprinted here. Alright, did that fill up my inventory? It did. Now there's going to be a dismantle crate somewhere. There it is. Alright. I don't know why all these random ingots are in my inventory and ores, but we need to just get rid of them. There's also this stuff, which I definitely don't need. Okay, all this Christmas stuff would be useful if I didn't have crates full of it back at the base. So let's clear all of this stuff out, and then we can just grab more when we need it. See, I don't need those, or one crystal oscillator, or 20 computers. I don't need 10 of those. And, alright, at least I have a good solid couple of spare inventory slots, so I can grab all of that. Alright, so now, if this works correctly, we can just blueprint alumina solution and get in one of those. So that makes the alumina solution. Then, can we make this all just one floor? Having this be like 5 floors just makes it harder to deal with, I think. So let's try to put this all on a single floor. So we have our alumina solution there, which outputs into that pipe. Then we go over here, we get a whole lot of space. And we get our heavy oil residue, then petroleum coke. Actually, it might be easier to do that first. Yeah, so let's dismantle you. Get the heavy oil residue in, then the petroleum coke, and then the stuff that are going to be connecting across weirdly can all go just directly next to each other, and that should be beneficial. Also, this is backwards. This, you need to point that way. So we get heavy oil residue. That power pole doesn't need to be exactly there. And want to move it somewhere out of the way. Let's actually just get that powered up. And I don't know, something like that. We'll place it in when we need it. So we have heavy oil residue. Then we take that and we make petroleum coke, which can just go directly there. Then let's power that power line up. So then we would connect that pipe to there, and then we go to our alumina solution, which is going to be taking from the Mark V belt of bauxite. So let's give it a little bit of space there, place it in. And then we do have enough space here. It's going to be a little bit close, but shouldn't ultimately be an issue. We just need to keep bringing the power along so that we don't fall out of the sky. You get connected in there. And now this can go in here and get us our final thing here, which is, let's see here. I guess when I made this already, where's the aluminum scrap? This one? Yes, it's this one. Alright, so then we put this in, and it can just go like here. I don't know, give it a little bit of space again, but nothing too crazy. Is that pointing the right way? Yes, it is. Alright. And then the scrap comes out here. And if we go one more row, we need to go into here, and I'm pretty sure I had the scrap smelting here, right? That's 960. This is the one that's 780. So then we get 2 of these per each of those, and then we are good to go. This is rotated wrong. So I believe it just goes down the center through that line of splitters, and then the outputs come along the edges and then merge up there. Alright, so that should be easy. And then as far as lining this up goes, we need a little bit more space there. And then we need a second one, like directly next to it. Preferably just as close as possible. Like that. And then that is just how much space that takes up. So now if we were to connect these across, you would go in to there, and you would go around and into there. And then we need to power these guys up, which is a bit more of a tall order than the other ones because of how much distance they are and how many machines are in that. Alright, so let's get it all connected up. So this is one row. So we need to then connect the rest of these belts up. So this is the alumina solution. This takes the alumina solution. So these very simply just connect across like that. And please go in the sides. I think that looks slightly better. Alright, then we've got this, which is water, which is one of the freshwater pipes. And it's 780, so it's going to have to be fed in via 2 pipes. So this is the petroleum coke, which goes around into this, right? Yes. Alright. So you come around this way. And go in there. Alright, so that is that. And then we just need to get the bauxite in here, the water in both sides of this input. Yeah, this is gonna be quite the process, getting all this connected up. So this has the polymer resin output, which we need to sink. And we can combine that up with the other ones in this row. It also has the heavy oil, which just goes across to there. Like so. Alright. So, if we get water in, and then connect the bauxite up, this should all work. So, step 1 is figuring out where the bauxite has to go. Step 2 is going to be finding where the water is going to be coming from, because that's not going to be trivial. This is the bauxite input, right? Right. Alright, so you get a floor hole right there, and you go in. So now we drop down, and I want to keep this sort of as vertical as possible, sort of, so that it's mostly, I want it to mostly just be taking up space underneath its own factory. Let's see here. There you go. And then we're going to have to curve at some point. Might as well be now. And then, I'm not sure which one is going to be most convenient connecting into which output, but for now we can just have this go into there, and we didn't quite get that right, but whatever. Alright, so that is bauxite fed in. So that's step 1. Step 2 is the crude oil, and then the water. So let's go over here, find our crude oil pipes. This is 78 crude oil. It's not that much. Our existing train network should be able to keep up with that. Is that what this is? Are you... Yes. That's what you are. Alright, so you are going to have to go underground to get underneath that. So we need to get you underneath the train network. And just over here. And honestly, you can just pop up just immediately once you're done. Okay, and of course it didn't snap in properly. So what if we connect it from that side? Nope. Alright, what if we try connecting it the other way? So you go down like that. Then that can go in like there. And we have our pipe of crude oil coming out over here. Alright, so then you just go across that. And we have crude oil in, which should cause everything up to the petroleum coke to start working. although the polymer resin byproduct might cause some issues. But hopefully it won't be a concern. Then we need our water. And we need so much water. So, how much water do we have in here? Really not all that much. That's a pipe there. That is a pipe. That's a pipe. Just those 2 pipes of water and then some headlift related stuff. Okay, so we're going to need to add in... What we're adding in 1,400, so more than 2 full pipes worth. So, we come down here. These are not producing around the clock. And they're not even getting especially close. But let's add more in. 1, 2, 3, 4, and 5. Alright, so these need to connect across. Like that. And then those go into there. And then these go together. And then we need a power pole to get them all charged up. And start filling those pipes. So there, and then you. And then that power pole can just connect sideways to that one. And all of those are now going. Alright, we need one more of these. One more of these batches. So we get 1, 2, 3, 4, 5. And I guess a power pole can fit in there somehow. 3, 4, 5, and then connect up. Alright, so now those are going, and we just have to merge them across. So they all have to get connected up. And then we need... Well, theoretically we need a 3rd pipe. Realistically, we can probably use this existing water. That's 50 something, that's 60%. Although this is going pretty close to full. Let's grab this purple power slug while we're here. Yoink. Never hurts to have one of those. Alright, so then... God, it would be so nice to have Mark III pipes. Did they, like... I'm pretty sure they might have spoiled something that suggests something along those lines. For, like, the 1.2 or whatever. Alright, so that is another 240. That's another 360, which should definitely be enough. So let's get this all connected up. And now we start bringing this water over. So that gets connected up, that gets an additional junction, that gets an additional junction, and these are all gonna have to come out. I think we can go around this way. And you can go around this way as well. And then you can just sort of get through that area barely and then come around. Ah, pipes. Just the absolute worst. Alright, so this goes up. It is connected in to this. So this is the pipe which does the magic. So let's add some extra space on it. And then give you 1, 2, 3 of those. So now these pipes need to sort of all organize up and come over here. So they have to go over there, they have to connect into that pipe to get the magic head lift. And then they have to go up the giant cliffside. So there you go. And you. And you. Alright, so then you go around and into these, however that is going to fit best. You are going to have to, it's very cramped in here, but we managed to fit them in. So now we can just bring these pipes over this way and up the other side of this wall here should be fine. So you go like that. You come around and then up like that. You go even a little bit further around and then up there. Alright, now we just have to do the fun job of actually dragging the pipes up the giant wall, which would be a whole lot easier if you could drag these further. There we go. There we go. Alright. Just keep on going until we get there. 1, 2, and 3. That one. And that one. And wait, did I do the math right here? I think I didn't do the math right. I think we need another pipe. Let's see here. Yeah, we're going to need another pipe, actually. Because we need to manually fill 3 of them with water. Not just 2 of them. So let's get that in. 1, 2, 3, 4, 5. So what we need is 780 times 3, which is 2340. So that is 600, 1200, 1800. So this actually is going to need to also be a full pipe, as opposed to just this partial pipe that we have here. Alright. Resource is not deep enough. We're running out of water. So you get an additional 2, which are just going to have to be squeezed in there by any means necessary. Then those combine up. And then this just goes around and into that. Okay, then we also need to power these, which I had apparently forgotten to done. Forgotten to done. What is that? I meant to say, which I apparently did not do, and I apparently forgot to do, and grammar just failed. Alright, so those all get connected across. and in there. So now those are producing water. Then we go over here and we get this line. So those two connect up, and those two connect up. Then we get junctions there, and there. And this one then goes into there, and then goes into there. And then we need a power line. So let's get that in. And get these all connected up. That's all of them. And now we just have to bring this pipe, I guess probably easiest to just shortcut directly backwards through here. And then make it back to this area. Okay, I think that train error is normal. I think just the way that train works, we expect that to happen. Because I set in a second train into the loop when probably only one would be enough. So the second one just has to spend a lot of time waiting. The point is, it's not actually a concern. Alright, so then you need to sneak up into there somehow. And now we can keep on going up. And the water is reaching it all the way up here, so the head lift trick is working. Alright, now we are all set to just keep on doing this. With 4 pipes instead of 3, but basically the same thing. Alright, so the water just goes up. And keeps going up. I really, once again, wish I had built my factory just like 50% even closer to the ground level. Just if we hadn't gone based off of the literal highest point of the map, that would have been very helpful and convenient. Alright, up we go. Just keep on going up. And these pipes are not perfectly straight, but they're close enough. As long as I don't accidentally cut any of them off and get them stuck, it doesn't really matter. Alright, then that one, and that one. Alright, so now we're up here, and we're trying to get over here. So that should be pretty straightforward. We just have to go over a little bit. 1, 2, 3, and 4. So now we can avoid that pipe. And then we just bring these onto a nice solid foundation up here. With some floor holes, so we get a 1, and a 2, and a 3, and a 4. So, now these pipes have to get into here, and they can go in a somewhat confusing way. You go in like that, you go in like that. You have to curve around there. You have to also curve around here. Gosh, if my scroll wheel would work, all the every game I play would be like a lot easier. You go in, and you come the last bit over and go in. Alright, now we've got pipes on the foundation as opposed to under it, which is going to be wonderfully convenient. So first off, we need to just take 2 of them and put them into that bauxite, and that should get most of the rest of the chain rolling. So this, actually, I think... No, yeah, let's go with these 2 for now. And these 2 come over here. You go in there. You come along and go in there specifically. So then we have 1,200 in here, 780 going out. We've got a good solid chunk remaining. Alright, so now we just need... Let's see, all this should... It should at least start doing something, right? Like, this has the petroleum coke. It's going to get its alumina solution to make some scrap. This is going to make some ingots. So that is cool. Now what we need is we need to finish off the whole line. So we need to just get all 5 rows of this in, basically, and then get the sinks set up. Okay, that foundation there isn't a problem. It doesn't need to do anything. So, the next thing we need is another line of heavy oil residue, which can be lined up there, but we need to be spacious enough to not have problems with the scrap. So, first of all, that row of foundations needs to go away, at the very least. Then this needs to go over here. And then we get all of this lined up. Okay, that didn't go quite as far as the others. Let's have them all go the same length for consistency. Alright, cool. So now we can set this up with these rows going down. And this is going to be a massive factory to get all of these in. But building massive factories is kind of what we're all about here. So let's see, I wonder if we should be able to actually just deal with this scrap production elsewhere to keep this stuff more compact. So let's do that. Heavy oil residue, part 2. Get you lined up there, and then we just want to give it a little bit of space for those rows which we want to be lined up. So let's have it lined up on that row. So that is in, but it's like half a tick far back. I don't know why that happened. I could have sworn I'd lined this up precisely. Oh, I'm dumb. I lined it up to the wrong thing. It has to be lined up to that. I lined the edge of the blueprint up to the edge of the refinery there. That's what happened. Alright, and then that lines up, and we get 2. So how many rows is that of space? It is 2 full rows there. And we can just keep placing these in. And we get another 2 full rows there. That's number 3. And then we are going to have to expand this out even further for another 2 of these. So let's get that. And heavy oil residue. Line it up. Give 2 full rows of space and place it in. Then 1 more. Line it up, give 2 full rows of space, and pop it in. So this is, what is it, 26 times 3 times 5. So this, all this isn't even a full pipe of crude oil, so we should be fine there. And then let's get this entire row powered on. And then we can connect the crude oil across. Okay, that's not how I want that line to go. I want you to do this. And then just across straight. As if it was automatically connected, just nice and neat. Have plenty of crude oil going into all of those. Then we can take our heavy oil residue, and that output is going to be obviously line by line, but the polymer resin, which is slightly less than 60 times 5 is 300, so we're going to need Mark IV belts here. Upgrade all of these guys to Mark IV. And don't worry about the water pipe supports clipping through. Let's just not notice that. Alright, so that is set up. And then we just are going to grab a little bit of extra space here for a sink. Special, awesome sink. In you go. And you get powered up. And go. Alright, so it's going to take a fair amount of effort for the crude oil to proliferate across this whole thing, but we should have the polymer resin going out at least. So that's something. And then these are not running because they've got massive reserves of both of the things. Alright, so next step is the petroleum coke. So this lines up there, and if I remember correctly, the left edge of everything was all lined up. Also, that's not rotated correctly at all. I don't know why it even did that. That's the correct rotation. So we get that in and place it. Then we go over here. And okay, apparently this is slightly off for whatever reason. That's fine. Just pop that in. So we need our extra space here. So let's run all of these foundations down. And is that's lined up wrong. There we go. Now we can get all of this correct. Alright, all of this is going along. And done. So that should be enough space at least for this row, and then almost enough for the next one. So we get our petroleum coke V2 blueprint. We get it all lined up and place it in. Then we go here, we get this one lined up and place it in. And that's all of them. So now we can hook the heavy oil residue across, like so. And there's no reason for these to be connected along the rows because the heavy oil is just going from one to the other. So that's fine. Then we just have to connect the power up, which it would make more sense to connect the power along the rows, but I'm not doing that here. I did power up this, so it is now going. Alright. So that is mission accomplished. We are now making petroleum coke in all of these. And also the crude oil seems like it has successfully propagated across. That's nice. Alright, petroleum coke check. Next up, we have our bauxite to alumina solution. So this is going to need this whole row to be built up. So let's just do that in one go here. And that should be enough space. Alright, bauxite to alumina solution. Is that this one? Yes, that's this one. Alright, so the pipes on this are going to be a bit more complicated. And also this takes up more space, so we have less room to work with. So that's a little bit concerning. Let's see here. You get lined up to there. And to there. I think that's correct. We just have to get all of these in. So you're lined up. And in you go. And I really hope I'm setting this up the right orientation. I think I am. And you go there. And now we've got all this. Alright, so let's get power across now. And then this is going to be the hardest part by a significant margin, I think, because we have the pipes which need to go along. So I think, let's see, this is 780. 1200 minus 780. 780 is 420. So if we just add in another pipe, we can run that along and add in the third water pipe just like at the other end of that, and it should work. And then we'll just have to do that one more time. Alright, so this water pipe goes around here. And we're going to need to be quite sneaky with its placement, because we need to leave some room for the other ones, but you go in there. So now we have... Yeah, wait, is that correct? So this is 600 going in here. 1200 go across these, minus 780 is 420 going down this way. So this actually needs to skip that row, I think. And you connect up there, and you go down and connect into, like, there, maybe? One, two, three, and then those two are going to be fed from the spare water, I think. So wait, no, this then... I think I'm just confusing myself. So we have 600 going into there with 180 spare. Then we add another 600. Wait, is that right? Why is this saying this? So we have 780 minus 600. So we need 180 more water. Then we add in another 600. Now we have 420 spare. Then we add in another 780 demand. Now we need 360. I don't know. We're just going to send the last pipe in, and hopefully the water will just figure itself out. And if not, we're going to have to just figure out where the even divisibles of 600 are, if they exist. Which I'm pretty sure they don't. So this pipe comes along this way, goes all the way down to here, and then loops in. Alright, so we have 780 times 3 is 2340. Then we have 600 times 4 is 2400. So this is 60 more water than necessary, which is totally fine. So these all are getting the water they need. Then the next step is the bauxite. So these all need... Well, actually, let's get all the machines in, because we need to do the looping for those two before any of this is going to work properly. I don't know. Let's get the bauxite in. It's a reasonable step to do. I don't know. Sometimes I worry too much about what order I should be doing things in when realistically it all needs to get done. So I might as well just do it in whatever order I feel like. Alright, so that goes into there. And then all of these go along like that. Alright, so those are all set up. Did I give these the right speeds? I did. Cool. Sometimes when you're just like going by muscle memory on something, you can't remember if you actually did it, which is an easy way to make a mistake when you're doing stuff like this. So I need to bring the other bauxite belts over. Alright, so let's see if I can just get these organized on how I want them to be and then hook the rest of them in. So we need you to corner like that. Then we need another one. And let's make sure to start this up in here to corner like that. And then go back to there. Then this one needs to... Can I get you lined up correctly? Needs to corner like that. And then we need one more for the number 5. So you go around the corner like that. Alright, so now I just have to get those 4 belts into those 4. And it should be straightforward. unless things go horribly wrong. And then from there, we should be relatively organized. Alright, apparently the curves are a bit sharp, at least for that first one. Okay, that doesn't work. You might need to be in straight mode to make your curve. No. Okay, this one then needs to change, because this is the one that's in the way. So you need to, I guess, point that way to begin with. And then you go straight across like that. And now neither of you clip. And these should then go just straight mode. It's too long. So you go like that. Then you're going to have to come back to there. And then snap into there. Alright, so that is a start. So now we have these all nice and organized and lined up. And we can just have them go around this corner. It should be the last corner they need to all go around as a group. Alright, now this one goes forwards. Actually, yeah, they all need to go forwards quite a lot. So let's get those all the way over. Alright, now we need to get these set up. So you get one, and you get one. Then we go over here, and these get them. Like so. Alright, so now we just have to connect these up in one last zigzag pattern. So you go... Oh, I almost fell. Almost fell there. You go to there, and then loop around to connect up to that. And then that will set the corner for all the rest of these to follow. So now they're going around this way. I could have made this path more direct if I had wanted, so I just could have gone like all the way up here, then all the way over there, but this is fine too. Alright, so then this goes all the way out to there, and then in. Now these two have to follow the same pattern, going very far over this way. This is a lot of underground. Oh boy, this one's got, it's got the crooked disease. Sometimes you have to just make them do straight mode, because default mode can be bad at doing straight mode can be bad at doing straight lines for whatever reason. Also, what on earth is going on here? Something got all messed up back here. Did you already go crooked? No, you look straight. Did you do something weird? Yes, you did something weird here. Alright, what if you just curve into that at default mode so that you aren't in the way? Alright, what is this belt trying to accomplish with all this nonsense? Just be normal? Man, I did not think that this would be the hard part. But here we are. Alright, so that can just go forwards a little bit. Yeah, something wacky happened with one of these two. I think this one, maybe. Got a weird bend in it. Hopefully that will have sorted out. Alright, then you go around that corner. And you can just continue forwards. And they keep wanting to, like, go up and connect into the conveyor lift through, or into a merger or something through the ceiling, which is very much not what I want them to do. I just want them to connect up like that. Alright, now we've got that in. And it seems like they're all working. Obviously, those ones aren't getting any water. These ones are, though, and they have produced some alumina solution. Alright, so that is cool. So now we just have to get our last couple of rows in. And the last row is going to be by far the hardest because it's the aluminum scrap, which isn't lined up properly for this. Like, we haven't given it enough space. So that's going to be a thing and a half. But for now, let's just worry about the scrap production and not the ingot production. So we get all of this zooped down there, like so. Okay, now we go over here, and we get our... Where is it? What's it called? Aluminum scrap? Yes, so this is the one which uses power shards, so we hopefully won't run out. Hopefully we won't run out. Apparently this is lined up with those, which is just ever so slightly off center of the foundations. I do not like that one bit. Also, apparently this is, like, weirdly aligned there. Alright, so that is lined up. That is lined up. In you go. Let's start getting them placed. And I guess we're just going to continue lining up with the other row, even though it's not perfect, because I guess probably because the blueprints were created differently. Alright, one more. And we do barely have the power shards for this. There we go. So those are all in. Now we just have to make the connections, which is Mark II pipes around the edges, like this. So that just goes along like so. Then we're going to have to get the petroleum coke around to here, which might not be fun. Alright, so that's the alumina solution. Next up, the petroleum coke. Now this one, we just sort of went around like that, and I guess we should be able to just do that for all of them. So you go around here, up this way, then around there, and in. And we just have to get that for all of them. So let's have the same alignment. So in the middle of that foundation and right on the edge of that foundation. And that should keep it nice and consistent and look sort of like one giant blueprint, although obviously it isn't. So that goes there, and around, and in. Alright, so that is the petroleum coke attached. And the alumina solution is attached for those which are producing alumina solution already. Obviously these two out here aren't. So let's get all of this powered up, like so. And now these are starting to produce. Alright, now it is time to make some scrap. So yeah, let's do the scrap next. We need 2 of these per one of these, so we need 10 total, 8 more than what we currently have. And we're just gonna cram them in as tightly as we can. And then hopefully not go too far out over the edge, although probably gonna go a fair bit out over the edge. Alright, so that... let's just line that up neatly there. And now it is time for scrap blueprints. Aluminum ingots Mark 5 belt version. And we are just gonna... is this facing backwards? Yes, this is facing backwards. So this, and we line it up and squeeze them in. There we go. So that's up to 4 total. That's up to 5 total. Here we are at 6. Yeah, this spacing is brutal. 7. We need 3 more, which isn't terrible, although we might have space problems. Alright, I can't center click blueprints like that. So that is number 8. This is number 9. And we ran out of power, but we can place that last one, and we're now out of iron plates, which is perhaps unsurprising that we've run out of something after all of that. Okay, now it also... okay, we need to get back into power range. And... oh, shoot. That's so annoying. We need to get back into power range. I wasn't able to swap to the jetpack fast enough to save myself. So now we just have to get all the way over here to these towers with water so that we can take the power lines there and get up. And then we have to connect all those scrap blueprints up to the power lines, which I was trying and failing to do. Alright, up we go. Up we go. It's fortunately not that long. The hover pack is pretty good at going up quickly. It's not as good like in a burst as the jetpack, but it doesn't, you don't have to like stop and start to retain fuel efficiency or anything, so you can just go. Alright, now we're back up here, and we need to get the rest of this power connected across. right, those ones, and those ones, and those ones. You know, this probably is making a noticeable dent in power just because there's so many machines. Hard to say. Also, it looks like our power production has basically just stabilized, and the fluctuations at the fuel generator have apparently been basically all resolved. So that's nice. Alright, so now this whole thing is all powered up. We need to get the belts across, which is not gonna be fun. Alright, I also just realized that these last two have their own water byproduct, which I'm gonna need to recycle into something, so I might actually only need 2 fresh waters. 2 of these to be powered by fresh water? I don't know, we'll see. Anyways, we go back here, and you go into there, and you go across to there. Nope, not that far across. You go across. Actually, do it. I think we need to keep this compact by going down and into there, because otherwise we're going to be constantly losing space for each one of these that we do. So you can just go across like that, and you can go back to default mode, back there, and then in. Was that not... That one was using partially Mark IV belts, which is no good. Alright, so this then has to go across like that. And then this one has to go across like that. Then we need you to loop into there. And we need you to bump down to there. Alright, then we just have those 2 left and these 2 left, so we don't need to worry about preserving the space anymore. We've done enough of that. Did I send that up a tick? I did. I don't want you to do that. Alright, I have to actually remove that conveyor pole because it's just going to snap to it otherwise. Alright, so then those 2 go to there, and then they go down. So you go in there, you come a little bit further, and go in there. Alright, so that is all attached up. Now we need to figure out the water recycling situation, because each of these makes 546 water and uses 780. So 780 times 5 is 3,900. 546 times 5 is 2,730. Okay. We need parentheses, I guess, for this. Oh, no, that was just an extra 8. So we can manage one of them. We can manage 2 of them. We can manage 3 of them. So then we would have... So we have 2 of them powered from inputs. The recycling powers the other 3, and we have 390 spare water lying around, which I don't know what to do with. All right, we're gonna have to import some limestone and make wet concrete to sink, I guess. So let's see. We could technically use the 390 to do another half belt. And I guess, I don't think we need that much aluminum though, to be honest. Like, this is already kind of a huge amount of aluminum. And I don't want to have a weird, like, partial thing set up there. So yeah, let's just sink the extra 390 water. The bauxite supplies are going to be rough just keeping up with this. So we go back to the water. These... Actually, wait, we don't have to do this in terms of full rows. We can technically stop midway along a row, right? So, each of these is 195 times 2 is 390. Alright, so let's get this sorted out. So you get disconnected. We have these 2 which are taking outside water. We have 546 times 5. 2,730 recycled water. Minus 780 times 3 is 390. So we have 3 batches plus 2 individual refineries. So if we just chop it there, then we have those are all being powered by input water. And yeah, that means we don't need nearly as much water as I thought we did. So we need 780 plus 390. 780 plus 390 is 1170 input water. So technically possible to do off of 2 pipes. So let's do that. And that is going to require, in order for that, you need to go all the way around here. Not like that. Don't do weird stuff. Just go like the shortest direction, and then you go in there. Alright, so that's 1200 water into this, which needs 1170. Then we just need the recycled water to go into all of those. So this, each of these is 546, meaning we can't really merge them up without breaking stuff. So let's instead just bring them over like this. You're going to go over there to save a bit of space in this area. We're very cramped, but it should be fine. So this batch of 5 makes 546 water. If that goes back and into here, that's this 390, and then spare can go down that row. So you go in like this, and then into here. Like that. Alright, so now that is all connected up to water. Then we need really, I think it would be best for this entire area to be connected up so that they can share water flows. So then, that 546 is mostly going that way. 546 minus 390 is 156 going into here. So then, that's actually a bit of a problem, I think, potentially, because we need a lot of water going into each of these setups. So you are going to need to come around here. I guess go down a little bit. And then in there. I don't know. This is probably not going to work. I'm probably going to have to spend more time staring at this whole water system to get all of this in properly. But so then that extra 156 plus that 546. I'm going to send this further over to this side, I think. Just put it in like there. Should handle that one. So then we just have these two left. And I think I've used that one, and I've used that one. I have not used this one. So you can just come along to there and just go into that. And then we can just send the rest of these in at all of these junction points. Now, a lot of this is sort of just resting on hoping that the water makes good decisions about what directions to go, which I highly doubt that it will, but you can always dream. And once we see where it's broken, if anywhere, then we can make steps to fix that. Alright, so we have water going through this entire section, which means the entire factory is starting to activate. We're seeing aluminum scraps coming out of those, and it won't be too terribly long before these start going. They're getting alumina solution now. And yeah, they are just taking a little bit to get set up. These are making the alumina solution. So yeah, now these are running. So we have scrap going to all of the scrap lines, which, if I recall correctly, each of these only makes 390 aluminum ingots. So then we merge these up into 5 belts and then bring them over to the train setup and get them hooked in. So they're going to want to go this way because the aluminum train is over here. And we are very much squeezing this in here. This should be more than enough space, but it's, you know, closer than I would like to running into a completely random, unrelated rail. This aluminum factory is so big. Alright, so that goes along. And realistically, that should be enough space there. So what we need then is a merger there, which goes from those two. Then we need a merger, I guess there is fine. Actually, no, we can do this merging here and then line them up later, and that will work better. So let's get that all set up. So you get a merger, You get a merger. And let's make sure that everything actually goes... Oh, that's wrong. How was I supposed to have done that? Right, this doesn't get a merger. It goes in to this one alongside you. Then you get a merger. And we just have to not mess it up so that every other one of these gets a merger, and the other ones just go into the existing mergers. So then we'll have 5 belts, and then we're going to have to sync them all, which we can probably do here, just immediately on the spot. And that should be fine. Alright, 1, 2, 3, 4, 5. Yes, that is the correct number. So now we need space for them to both sync and then loop out into this main line. So let's fly over here. And I imagine most of this is going to be shut down because of the lack of room for outputs, which is fine. We're going to fix that shortly. So this... Let's have the main line go just like out over this way and give us a little bit of space in here for each of them to line up with it. So we're going to do something like that. I don't know exactly. But we need a smart splitter here, which has a side output directly to a sink, and a front output which goes directly forwards. And then that connects up to there. We get right overflow, and the sink can attach onto the nearby power. And now that is going. So now we just need to do that for each of these. So you are going to get a smart splitter and a smart splitter. And we're just going to do this in phases so we don't have to be constantly flipping through menus. One more smart splitter. Okay, then we need our space for the sink, which is going to be like that, and then the sink goes in there. So let's bring this space down and connect all of that up. Again, we don't want to be going through menus as much as possible. So do all the foundations now, then all of the sinks, and then all of the belts. Alright, sinks are in. So now we go belts, boom, and boom. That front one we've already set up preemptively. So that. Then we go back to this one. And we go back to this one. Alright, now we power up all the sinks, so they can just attach to the nearby power lines. Fortunately, there are a billion power lines in this area, so that's not going to be an issue. Okay, then we need to get that one, and this is right overflow. And let's paste those splitter settings all the way across. And one more. Alright, so now that we have that, the final step is to get the aluminum out and just around the sinks. So this is the first one which is going to have to worry about that. So you are going to need to go up this way and over here. And then we just need to get the other 4 lined up with this. And wait, hang on. This needs to go this way at first. Like that. And then back. And then the rest of these also need to line up. So there needs to be 4 of these, because that one is already doing its own separate thing. And then this goes like that. Okay, now we just have to get all of these nice and aligned, which doesn't really matter, but is nice. So now they're all lined up at the same lengths. It'll be marginally easier to drag them around. Alright, so the next thing we need is we need these to go up here. And then we'll be able to see them and connect them in with the specific belts that they need. Alright, so those are in. And now you go around to there. You to come up that way. And we need that to go a little bit further back. For these to come back with them. Like that. You get connected up to there. And you just go there. Alright, so now that is going to do its thing. And is this not set up right? Why is this going... Why was that going at partial speed? Oh, because this is already something, separate things being merged up. That's why. Alright, so that's that. Now we just need to get all 5 of these belts into the train network. And also technically merge up with this last one. Alright, so this is going to be the last major step in this process, which has consumed the entire stream. I was hoping to get started on the Propulsion rocket factory proper, but it seems not. So this is the aluminum output here. Alright, so what's going on here is we are using both the top and bottom row here, which I don't want, because we need to just convert all the bottom inputs into this new system. So let's tear this out. I don't know if I want to even keep the old system running. I think I technically should, like there's nothing wrong with it, but I need to just convert it to only input into the top side of this. It's not like it's less efficient or anything. I mean, it's using the exact same recipes, so that doesn't really matter. Alright, so this is the one which needs to be changed. You need to come down to, like, up here somewhere. And then... yeah, this is incredibly cursed. But if you just go in, like, there... actually, no, wait. I think you go in there. So now this one is just dedicated going into this, which is fine, I guess. This one is going into this whole top row, which is mostly those two. This one is going into this whole top row, which is those three. The top row is not going to be evenly balanced, but I don't really care. The bottom row is going to be perfect, though. Bottom row is going to be a full belt from all... One full belt from each until the bauxite runs out, at which point I will be sad. So these all go in, using all the aluminum in order to get the aluminum into the train. Alright. So then those have to come over to this side of the tracks and somewhere like here. And let's see here. I guess it would be easier to just bring those over here and then figure out where exactly they need to go, but I have a vision in my head of how it's going to work, so let's just do that. 1, 2, 3, 4, 5. And then we just have to get all of that in so that it doesn't look silly. And then these are going to be going down in here. So like that. And then they go across over this way. Alright, now we need to get these all set up. And I really hope I got the alignment right for these to be convenient. Let's see, so you can just go straight across. Actually, you can align up slightly, what was it, like that? No, it was slightly to the side of it. So we have to take that out. And you are like there. And then straight forwards to that. Then you can get swapped to straight mode. And alright, you're doing funky things there. I presume that is just because of the spacing being too tight or something. So you curve in like that. Then you can come around to here. Straight mode does seem to... okay, it doesn't quite. So this guy is the problem again. We're going to have to take you out, rotate you that way, and let's see here. If we can get you in properly, something like that works. It's ugly, but it works, and that's the important part. And then we have this one going in on straight mode, which means the rest of these can as well. So those are all nice and lined up. And now we just have to bring them all the way across to those. And that one more. One more belt goes in there. Alright, so now you just have to get from here over to there, which is really covering quite a lot of space. So I think we want to take a bit of a zigzag path just so that we aren't wasting this entire massive square. It doesn't technically matter, but let's go there. And then the rest of these make that same turn. Three and a 4 and a 5. Alright, let's get foundations underneath these last couple. Not dismantle mode. Build mode. Alright, so that looks good. And then these 5 belts are going to go all the way down to like here before turning. Let's see, where do we want them to turn? I don't know. Let's just take them at least down to here, and then a little bit further. There we go. And one more. Alright, so then you are going to just go basically as far as you can without running into the pipes, which is going to be there. Alright, then the rest of these are going to line up with that. And you, and you, and you barely do any movement past the turn because that's how corners work. Then this goes forwards. And there's just going to be one more turn, I think. Yeah, should be just one more turn. Alright, that was going to do something evil with straight mode. So while we're on a straightaway, we can just use default mode to prevent weird crooked angles from happening. So this all goes forwards. We are a bit far away from power at the moment, though we're not going to be getting further away from power as we go, so that should be fine. Alright, so then we extend that out a little bit more. And now I think we just take this one like all the way to its destination so that you can see where they're going to be lined up. Alright, so this is going to be the short one, which only has to get out to here. So you're going to do something like that. And then in there. Then the rest of them are going to have to go all the way across this area. That's a full tier 3 power line. Power lines in general are a bit scarce. Let's get you over there. That should be more than close enough to get all the rest of these going. Okay, then these go forwards. And we're going to be breaking away from the belt we've done already to get the rest of these lined up into their batch of 4. So that goes along. Just get a couple more of these guys in. We are almost there. almost done with setting up this aluminum, and then we're going to have to start worrying about fixing any problems with it. Alright, I can't figure out how that is supposed to align, so we're going to do it from this side. And it's... yeah, it doesn't quite make it to the corner, so let's get that in. Get these foundations in. And those foundations, yeah, we basically used all the space we have. We have like one foundation of spare. There we go. Those are all in. That last one was just barely not long enough to line up the same as the others, but should be long enough to do this. And we have our belts now running. Gosh, that is a pretty awesome sight. However, it's not staying awesome. So this one isn't outputting enough water. And I would imagine that is because of speed-related issues. I see, it should be, right? I mean, this is... okay, so what we need to do is we need to make sure that water is only flowing in directions we intend it to. So this is going here and going that way. So this needs to be handling all of that. So I think we want a valve pointing that way just to control the direction of flow so that we don't have water from here going over there. And let's see here. If I remember, this was 546. And these two were 390. 546 minus 390 is 156, which isn't even enough to fill that. So we are going to then maybe another valve pointing that way so that this water doesn't go any further than it's supposed to, and this covers all of that area. Alright, so this is 546, and 40-ish of it is going here, which means we have 500-ish going to there, and to here. Oh wait, this is short on bauxite. Alright, so that's fine then. That's just the other problem we would expect to have. And so this is, if we have some of these that are short on bauxite, why is it just like this one specifically? How did that happen? Are all the rest of these fine? None of the rest of these are short on bauxite. I mean, yeah, the rest of these are having looping-based problems. This row specifically, did I, like, sneak a slow belt in here or something? What speed is this? That's Mark 5. All of this is a blueprint, which is shared with the others. Okay, bauxite has just stopped entirely here. So it has to be... it's weird that it stopped entirely for just one. I guess that's because it's getting drained unevenly. Alright, so let's poke a hole in the floor so that we can get down here. And now it is going again, it looks like. Alright, so this is this belt. It's the second belt in. I don't know, I should be able to see it. It should be obvious from the trains that one of them is going to be like nearly empty or something. I'm just going to follow it back just in case. It is this one here. And sure enough, you are nearly empty, while the rest of these are doing fine. Oh wait, no, they're not doing fine. Some of they're struggling to various extents. Alright. Now, we're going to need more bauxite input, basically. So this theoretically would be enough if it could get there fast enough. So this is outputting, it looks like just 2 full belts of bauxite, whereas this one has the room to be filling up over time. This one is also doing the same, and this one is filling up over time, and this one seems to be slowly filling up. Okay. So they are all technically not outputting 2 full belts of bauxite, but for some of them it's a lot closer than others, which is causing problems with the unloading process, because every time that these trains get filled, these ones specifically are being asked to output more bauxite than they have available. Now, ideally, I mean, this is just burning through like absolute crazy. 958 a minute, 1,000 a minute here. So none of these incoming transfer rates are enough to keep up with the massive drain that I've just added. Is this a full train? No, this is not a full train. Alright. So we have hit the limit of our bauxite supply, which I knew was going to happen. And these reserves aren't just even going to last long enough for the train to stop. And that's very worrying. Because that's a thing where, like, adding more trains doesn't solve that problem. The only way to solve that problem would be to get Mark 6 belts, which I don't have. So, or alternatively, of course, to balance it across the rest of these. Alright, there's Bauxite Train 2, and it is mostly empty. Alright, so this... We're going to need to figure out a way of solving this problem. Because some of these are burning more bauxite than the others, and that is becoming an issue. It's probably going to result in the output getting jammed, because that's what supply shortages pretty much always result in, unless you have some system in place to stop it, which currently I don't. Now, as far as the bauxite output, we are doing more than fine. Like, all of these are filled up. So, theoretically, we can now add in just like all of the aluminum demand we could ever want, and this will keep up with it if it doesn't jam. If it jams, then all bets are off. And we can do a fun trick to prevent it from jamming. Oh, there comes the fuse frame aluminum. This might be its first trip since the upgrade. If it is, it'll get enough aluminum to last a while. If it isn't, then it just drains aluminum like crazy. I think probably both are true. So this... We're going to need to figure out how to prevent this from jamming, basically. Because I don't think there's all that much that I can realistically do to get this to work better. Like, if these want to be draining nearly 2 full belts of bauxite, there's very little that I can do to prevent them to, like, prevent them from getting disrupted when a train shows up. So instead, the part of the solution I need to be focused on becomes making sure that they don't get disrupted. Like when a disruption, a temporary disruption is fine, right? If some of these are only running at like, 90% or something, that's okay. It's not ideal, but it's fine. But if they end up getting completely bricked with too much water, too much alumina solution, whatever, can't run, then that's an issue. We can't have that. So, this should be fine. Yeah, we should be okay. I think it'll work. We're just gonna have to. I guess we're probably going to have to hook up the water return system with another, or maybe even just the same thing that uses over here, this copper thing that uses water, so that if this gets jammed, that will drain it. And I think that should be fine. But I think that will be a job for next stream, where we're going to just wait to see if it actually is a thing that comes up in practice. And we can see some of these are full belts, some of them, well, it looks like none of them are completely full belts, except maybe this one. But there are occasional disruptions, but it's pretty dang close to 5 full belts of aluminum. And that is pretty cool, because that's enough aluminum that I shouldn't have to worry about upgrading it for a while, especially in conjunction with the other aluminum that I have on the other row. So with that sorted, next stream, I guess we're going to be moving in to making thermal propulsion rockets proper, which is gonna be a lot of other steps. Like we have 33.385 pure iron ingot refineries to do. Let's see, what other big numbers of machines are there? I think that's probably the largest one. Oh no, we've got 18 assemblers for stators, 15 manufacturers for modular engines, and that's with importing 10, by the way. So yeah. Thermal propulsion rockets, we're going to be working on that one for quite a while. So make sure to stop by for that if you are interested. Otherwise, I will just be here as usual tomorrow, unless something weird happens. I'll be playing in Factorio, and then we'll be back to Satisfactory on Friday. So yep, I stream every weekday from 2 to 5 Eastern Time. So make sure to follow if you're interested in seeing what I do. Play various factory building games. And we're making a lot of progress in most of them. What is that, by the way? Those are not properly spaced. Anyways, shouldn't get distracted. Thanks, everyone, for hanging out. Had a lot of fun. It was satisfying building just a... This is a pretty clean factory, like all things considered. Pipes are going to be a bit scuffed no matter what you do with them. But this is pretty clean, and I'm pretty happy with it. So yeah, that's going to be it. Thanks for hanging out. See you next time.